In this next example, we'll consider the Maclaurin series for functions of the form 1 plus x to the power of k, where k can be any real number. So like usual, what we'll do is we'll try and find the coefficients of our Maclaurin series, right, which again are going to be the derivatives of our function evaluated at 0. Right, so we can fill in this formula like we've done in the other examples. So maybe if we do a couple of derivatives, evaluate them at 0, maybe we can recognize a pattern that we can apply to get all the terms of the series. X to the third. Okay. Well, let's start with f of x equals 1 plus x to the k. Evaluated at 0 will just be 1 to the power of k, will just be 1. F prime of x will be k, 1 plus x to the k minus 1. And evaluating f prime of 0 would give me k. When I take the second derivative, I get k times k minus 1 times 1 plus x to the k minus 2. And so the second derivative at 0 would just be k times k minus 1. And let's take the third derivative. It should be k minus 1, k minus 2. One plus x to the k minus 3. And so evaluating this at 0, we get k minus 1, k minus 2. And so on. If we continue this, we might recognize that there's a pretty easy to see pattern. So what would be the nth derivative? Well, it would be k minus 1, k minus 2, down to k minus n plus 1. Right. And 1 plus x to the k minus n. So the nth derivative at 0 would just leave me with k minus 1, k minus 2, and so on, all the way down to k minus n plus 1. So we can fill in the formula that we have above here. We see that f of 0 is just 1. F prime of 0 is k, so we have kx. F double prime of 0 would be k minus 1 over 2 factorial times x squared. And then f triple prime of 0, k minus 1, k minus 2 over 3 factorial x cubed, and so on. And we can imagine here this pattern would continue. So we can write this as the sum. With these coefficients, k minus 1, k minus 2, down to k minus n plus 1 over n factorial x to the n. Okay. So in fact what we've done here is we've derived a formula for what we're calling the binomial series. So the binomial series, right, looks like this. parentheses here. So it's, yeah, k minus 1 down to k minus n plus 1 over n factorial. We can use the ratio test here to show that it's convergent for absolute value of x less than 1, so it diverges outside of that range. Now these coefficients here, we can summarize with the formula k choose n, which is exactly that formula that we have there, k minus 1, k minus 2, and so on down to k minus n plus 1 over n factorial. So oftentimes a shorthand way that we can write this formula will be just k choose n, x to the n. So we say k choose n, which mostly comes from when k is an integer, this is a counting formula, and so it would be used to do kcn, which is the combination formula. But here we're using it as a more general version where k here can be any real number. Of course, n has to be an integer, but k can be any real number. So let's just practice this formula a little bit, get the hang of it. Find the Maclaurin series for f of x equals 1 over the square root of 4 minus x. So what I'll do is try and manipulate this a little bit to get it into the form of the binomial series that we had a moment ago. First I'll write this as 4 minus x to the negative 1/2 power. What I might do from here would be to factor out a 4 from the parentheses there, so we get a 1. Here, and then x over 4 remains. Okay. Notice 4 to the negative 1/2, that would be 1 over the square root of 4, so that's 1/2. And then because I want 1 plus x to the k, I want it in that form to use the binomial series formula. We'll write minus 1 plus negative x over 4 to the negative 1/2. And so what I can see here is that we'll use k equal to negative 1/2. And then we'll replace x with negative x over 4. So I can just then put those values in here and here to get the binomial series for this function. It'll be 1/2 series from n equals 0 to infinity of negative 1/2, choose n, and then negative x over 4 to the n, which here I'll write this a little bit more clean. So negative x over 4 to the n I'll write as negative 1 to the n, x to the n over 4 to the n. Now, what might help here would be to think about the first few terms of the series, just to visualize what we've found here. So we know that here, when negative 1/2 choose n, we'll start with just 1. It always starts with 1. And then, because it starts with n equals 0. So remember, it always starts with 1, and then it's kx, and then it's k minus 1 over 2 factorial x squared, and so on. It starts with 1. And the next one would be k. In this case, k is negative 1/2. and instead of x, it'll be negative x over 4. Okay. And then the next one will be k minus 1, so that'll be negative 1/2, and then negative 1/2 minus 1, 2 factorial, and then we'll have negative x over 4 squared. And then the next one would be negative 1/2 minus 1, negative 1/2 minus 2 over 3 factorial, and then negative x over 4 cubed. Okay, so you can see the terms are going to get a little more complicated as they go, but here at least the first few terms we could simplify pretty nicely. So let's see what they simplify to. So let's see, this will be negative 1/2 times negative x over 4, so that'll be plus x over 8. And let's see what we have here, negative 1/2 times negative 3/2, right? So that'll be positive 3 over 2, and then divided by 2. Over 4 then, right? And then here we'll have x squared over 16. And then let's see, here in the next term we'll have negative 1/2, negative 3/2. Again, that's negative 3 over 4. And then a negative 5/2. So I think, let's see, that'll be 3 over 4 times negative 5 over 2, so that'll be negative 15 over 8. Okay, so let me write that. We have the 3 factorial, which is 6. And then x cubed over 4 cubed, so that's x cubed over 64. Okay. Anyways, so you can start to see now how these coefficients will be formed. They get a little more complicated as the series go, although they do start out a little bit simpler. Now let's think about what its radius of convergence is. Remember up here when we have just an x here, this will converge for absolute value of x less than 1. In this case, remember we actually substituted negative x over 4. So it'll converge when the absolute value of negative x over 4 is less than 1. Which means the absolute value of x over 4 is less than 1. So the absolute value of x is less than 4. So here our radius of convergence is 4. So this series will be good for x between negative 4 and 4.